One invalid database row can break an entire application, and most developers make it possible without realizing. When building applications, it's tempting to trust application code. A user submits a form, an API validates it, everything looks fine. But eventually, another API appears, a migration runs, an admin tool gets added, a script updates, and suddenly invalid data enters the system. Now you are debugging the problems that should have never existed in the first place. For this AI interview simulator, I wanted the database itself to enforce business rules, not the front end, not the server actions, the database. Because databases are the final layer every write must pass through. That's a non negotiable. Every interview attempt has a status, not a dozen of statuses, but exactly five. First is in progress, then submitted, completed, failed, and last is abandoned. That's the entire life cycle. The most important part here is consistency. Every attempt must always be in one of the valid states, nothing else. There is no tolerance for like a sixth state or a temporary state or a transition state. No. Either it is the five states or the row does not exist. Simple. A lot of developers store their statuses as plain text. That works fine until somebody accidentally writes complete with a C small, complete with capital C, complete with all caps, or something else. Like they can type anything because it's a plain text. You can practically write anything. Now your analytics will break. Your filters will become meaningless. Reports will become confusing and honestly, they will lose their value. Instead, Postgres enforces valid values using check statements. The database literally refuses the invalid states. That means bad data never enters the system. Now, why I'm saying that bad data entering the system is worse than having no data. See, the point is people think that having data is everything. No, it's not. The problem is that having data and having useful data are two very, very different things. Because if you follow AI models or if you follow anything, you will hear about the term called data poisoning in AI. That's the thing. If your data quality is bad, your everything, like your analytics, if you're building an AI model on top of it, if you're doing anything, basically using that data will corrupt everything down the line and it will make you make bad decisions, which is not ideal. See, states alone here is not enough. We also want timing information for our application. Each attempt stores started at, completed at, and duration seconds. Now we can easily answer the queries like how long the interviews take, which topics usually take longer time, which users abandon most frequently. Without these timing data, this insight will disappear forever. You can't manufacture it. Now, this performance index will become important later. Imagine you have thousands of attempts. Now, users will open their history pages. Without indexes, what will happen? The queries will become slower. So, to tackle this, I added composite indexes around common access patterns. See, I haven't added index for every column because that makes no sense at all. That will only overload your database and you will burn money on things which you are not going to even use it. So, always prefer common access patterns, and these common access patterns are going to change with the type of data you're going to store and with the application you are building. Here we are building AI interview system, but in future if you are building some other application, the patterns will be different. So that's something you have to think about and then you experiment about it. You also think that how these things are going to be used and so on. So what I did was like I created an index on user ID plus created it. That's one of the common access pattern for this. Now the history queries will stay fast as the data grows. Now, see why I'm against, or you can say why I put rules of business on database level, not on application level. Because application code can be bypassed, APIs can be bypassed, database constraints cannot. Every write must be reaching the database. Like there is no objection on that. If the write is not reaching the database, then you are not storing the data. That's why database is the strongest place to enforce business rules. Not because it's elegant, but because it is reliable. And we need reliability when we are dealing with data. A user starts an interview. First, the status will become in progress because user is still interviewing, like they are entering the answers. Then user will submit the answer. Status will become submitted. Then AI starts evaluating. After some time, AI evaluates and status becomes complete. Now, somehow AI fails. Can be any error. So the status turn to freeze. Now, it can also happen that mid interview or mid practice, they have just closed the browser and never returned. So the status will become abandoned. Now, every transaction becomes explicit. Every state is measurable. Every row remains valid. There is no confusion. You can just simply see the status and you know, okay, what is the user's behavior. No need to second guess or no need to make some complex logic around it. You just simply know that no, because you have put statuses properly. Now, this is the mindset shift I want to talk. See, we created many constraints for ourselves and many developers. It's a pain. Let's be very real. Whenever we create constraints like that, it results in pain and it results in friction because you are not able to move as fast as you want. You will need planning, you will need migrations. But the trade off is very simple. A slightly slower development will produce much higher quality of data and much higher quality of user experience. For production experience or for production systems, that's usually worth it. Most developers think that database just store data. See, database store data, but good databases prevent bad data. And that's the mindset shift. You not only store data, you also make sure that data quality remains useful. Like you should not store junk because see, storage costs money. Everything you do in development, when you scale, you are going to use infrastructure, you are going to burn money. So use money properly. Next, we will connect AI evaluation into this life cycle and deal with something much harder, making AI output predictable.